Electrochemistry. So we come across the reactions called as redox reactions. So redox reactions usually involves two types of reactions together taking place always. One is reduction reaction and another one is oxidation reaction. So we have seen that all these the reduction reactions and oxidation reactions uh, always takes place together only. So whenever reduction takes place, oxidation also takes place. But suppose if you separate the two reactions, reduction reaction and oxidation reaction, you separate it. And if you conduct this in two separate chambers, this is the chamber 1 and this is the chamber 2. So then it is possible to connect these two reactions by using a wire, external connecting wire, so that the electrons can move from the oxidation chamber to the reduction chamber. Usually in the oxidation chamber, the electrons are liberated from here to, so the reduction, the electrons will move. So, but usually we don't come across only reduction reactions or only oxidation reactions. So here in the batteries or in the electrochemical cell, so we are doing the same thing here. So reduction reaction, oxidation reaction will be separately conducted, and we are going to produce the electricity. So now we shall study about briefly about what are electrochemical cells. Electrochemical cell means it is a cell involving so the conversion of electrical energy to the chemical energy. That means electrical energy is converted into chemical energy, or chemical energy can also be converted into electrical energy. So these interconversions we are going to study in the branch of chemistry called as electrochemistry. So electrochemistry means it is a branch of chemistry where we are going to study about the spontaneous conversions of the chemical energy to the electrical energy and the non-spontaneous conversion of the electrical energy into the chemical energy. So these conversions we are going to study. So electrochemical cells will be of two types. So the first one is the electrolytic cell, and the second one is voltaic cell. So electrochemical cell, we are going to pass the electricity, and we are going to conduct a chemical change. So chemically it will be affected. So chemical change will be brought about. But in voltaic cell, the we are from the chemical energy we are going to generate electricity. So these two cells, electrolytic cells and voltaic cells, work in opposite directions. So these two constitutes the electrochemical cells. So voltaic cell is also called as the galvanic cell. So the main purpose of studying the electrochemistry is, so in nature we come across different types of redox reactions, that is natural reactions, chemical reactions that can be studied by using this one, and new types of chemicals and instruments methods can also be studied industrially. It will be important, and also we can prepare industrially new types of the chemicals also, which can be prepared also, and also the sensors. So these different types of sensors works on the principle of the electrochemistry, etc. So this shows the importance of the electrochemistry in daily life. Next, we shall study in detail about the electrochemical cell, that is voltaic cell. Voltaic cell means it is a cell in which the electrical energy is generated by using the um, chemical reactions. Generally, the very famous cell is called as the Daniel cell. So Daniel cell, it is made up of the two half cells. This first one is the zinc half cell, where zinc metal is dipped in zinc sulfate solution, which is 1 molar. This is 1 mole of zinc sulfate solution. And another half cell is the copper half cell, where we are going to dip a copper metal in a copper 1 mole copper sulfate solution. So these two cells are interconnected by using a salt bridge. This is the salt bridge. And this will be connected to a voltmeter, so that it shows the deflection and gives the voltage generated here. So this setup is called as the Daniel cell. So this Daniel cell, here, it generates about a voltage of a EMF of about 1.1 volt of EMF will be generated by using this Daniel cell. So here the zinc in contact with this zinc 2 plus ions and copper in contact with copper 2 plus ions are called as two half cells. When these are connected together, so the electricity generated here is this 1.1 volt is. But similarly, we can make also different types of electrochemical cells. Not only zinc and sulfate, we can change the any one of the electrode. So there different types of combinations can be possible. So similarly, other type of combination is the copper and zinc, copper and silver. If you use the copper here it becomes the uh, anode, and 1 mole of copper sulfate solution, and it is represented symbolically like this. And it can be clubbed with the silver nitrate, which is aquated 1 molar solution, and club the cell is represented like this: copper sulfate, double line, silver nitrate, silver. So this halus, the anode will be represented in the right hand side, left hand side. This is the left hand side, and this is the right hand side. Always the cathode will be represented in the right hand side, left and right hand side, and toward the left hand side, anode will be represented. So here anode carries the negative charge, and cathode carries the positive charge in a Daniell cell. And these charges interchange in the case of electrochemical cell. In the case of electrochemical cell, anode will carry positive charge and cathode will carry negative charge. So we can convert the Daniell cell into the electrochemical cell into this is a voltaic cell into electrochemical cell, like this. If we connect a external voltage which is in the opposite direction, this is the external voltage applied to this in the opposite direction. Opposite direction in the sense, so that is we are generating 1.1 volt, means if you pass the electricity 1.1 volt in the opposite direction, then what will happen? So up to when still this voltage is less than 1.1 volt, external applied voltage is less than 1.1 volt, the electrons will flow in the opposite direction, that is towards the zinc electrode to the copper electrode, and current will pass through in this opposite direction. Current will be in the opposite direction. So this will be the case. So we go on increasing the 1.1 the opposite current till it becomes 1.1 volt. When it becomes 1.1 volt, then the electricity generated by this will be 0. E is equal to 0.0 volt. So that means opposite external voltage applied to this cell, so stops the chemical reaction taking place in the cell, and its voltage will be the voltage of the cell. So now suppose if you increase the voltage of this cell greater than this, greater than means, so greater than 1.1 volt, if you increase the voltage, then what will happen? So the external applied voltage will be in the opposite direction, and it will be having the it will make the reaction to reverse. That means, so the whatever the reaction taking place, anode and cathode will be reversed, and the signs here will also be reversed. The electrode potential. So electrode potential means it is the potential difference that is developed here between the two electrodes. So the potential developed between the two electrodes is called as the electrode potential. So the potential which is determined when the concentration of the solution is in standard condition. That is one is 1 molar, and the temperature is about 298 Kelvin, and the pressure is at 1 bar pressure. These are called as standard conditions. Under these standard conditions, the potential measured is called as standard electrode potentials. So this may be called as standard. So the potential, the magnitude of tendency is the according to IUPAC, the potential of a cell is measured by taking the reduction as the standard. It means, so a particular half cell can act as the oxidation electrode, or it can also act as a reduction electrode, depending upon the nature of the other electrode. On nature of other electrode. Therefore, the potential measured for a cell can be a positive value or it can be negative value. But to avoid this confusion, the IUPAC has announced a reduction will be taken as the standard for measuring the electrode potential. Accordingly, so whenever the reduction reaction takes place, the potential value, if it is positive, then it will be called as positive value. If it is negative value, it will be called as negative value. So whenever reduction takes place, it will be given positive value, and oxidation, whenever it takes place, it will be called as a negative value. So this is according to IUPAC convention. Now we shall study about a cell potential. So the cell potential is entirely different from the electrode potentials. A cell is made up of the two half cells that is combined by using internally by salt bridge and externally by using a conducting wire. The maximum potential that can be generated can be represented from a cell is represented by the E cell, that is cell potential. The cell potential is the potential difference between the two electrodes of a cell is called a cell potential. So this also can be expressed in the standard conditions. So if you maintain the standard conditions like the concentration should be 1 molar and temperature is 298 Kelvin and pressure is 1 bar pressure. If you maintain the standard conditions, then you can call this cell as a standard cell potential, represented as del E naught cell. The potential of a galvanometer when no current draws is drawn through the cell. So without wasting any current, without drawing any current through the cell, if you measure the EMF of the cell, this will be called as the EMF of the cell, that is the electromotive force of the cell. So electromotive force means it is the voltage measured without drawing any electric current through the cell. Now we shall see the electrochemical conventions. While writing the electrochemical cell, we follow the following conventions. The first one is the interface between the two that is a solid and a liquid, that is the electrode and electrolyte interface. This is represented by a simple bar, or it is also represented by using a semicolon like this. So anyone can be used. For example, a copper rod dipped in a copper sulfate is represented like this: copper in contact with copper sulfate of 1 molar concentration, or it also be can written as copper semicolon copper sulfate in the bracket 1 molar. So like this you can write. A second convention is the while writing the oxidation, the electrodes, we always represent oxidation electrodes towards the right hand side, the left hand side, and the reduction electrodes towards the right hand side. The oxidation electrode will be called as anode, and the reduction electrode is called as cathode. This is always a right hand side electrode. This is a left hand side electrode, and this cannot be interchanged. And the double lines will be used for indicating the salt bridge. And the overall cell can be represented, for example, if you use the silver nitrate and the copper sulfate cell, that is copper in contact with the copper sulfate, double line, that is a salt bridge, silver nitrate AgNO3, 1 molar, and contact with its metal silver. So this can be the same complete cell is represented like this. So you can notice that here the copper sulfate and copper is in contact with copper sulfate. So here in this case, silver nitrate, when it is the electrode is present in the silver nitrate, this can act in the left hand side electrode, that is a oxidation electrode. When the zinc is present along with this one, this will act as a right hand side electrode, that is a reduction electrode. That is same electrode can act as an oxidation electrode or reduction electrode depending upon the other electrode present here. If other electrode is silver nitrate, this copper sulfate becomes an oxidation electrode. If the other electrode is a zinc electrode, zinc dipped in zinc sulfate solution, then copper sulfate will act as the right hand side electrode, that is the reduction electrode. The EMF, third convention is that the EMF of the cell is calculated by using the equation E cell is equal to E right hand side electrode minus E left hand side electrode, or it is also called as E reduction electrode minus E oxidation electrode.